So let us consider the problem. So x of t, so that has been given by u of t plus 2 minus u of t minus 1. Similarly h of t, so which is equal to u of minus t plus 2. So we have to find out the output. So that means they are told evaluate the continuous time convolution integral. That means convolution between x of t, so and h of t is nothing but my output signal y of t. So the formula which has been given by minus infinity infinity x of tau into h of t minus tau, so d tau. So now look at here, so we have to sketch x of t signal. So x of t, so which has been given by, look at here, u of t plus 2. So if I write u of t plus 2, then it starts from minus 2. So then if I write u of t minus 1, it starts from 1. Subtraction between these two will yield the rectangular pulse from minus 2 to 1. So that is nothing but my x of t. So directly, so I will write x of tau. So because I am interested in x of tau, so I have shown x of tau. So that is minus 2 to 1. So let us draw h of t. So if I draw h of t, how it looks like? So look at here, t plus 2 means it starts from minus 2. So then h of we have u of minus t plus 2. So its reflection I have to take. So that means it will start like this. So this is my actually h of tau, you can call here. So it is starting at plus 2. Okay. So now I have to find first h of minus tau. So again if I draw h of minus tau, so reflection of this one, so it starts from minus 2. So but actually I am interested in h of t minus tau. So that means somewhere it will start like this. So this will become t minus 2. So remember, when I put t equal to 0, so I should get h of minus tau. So I am getting at minus 2. So this is nothing but my h of t minus tau. So this I am going to consider. So h of t minus tau. So that I am going to draw here. H of t minus tau. So this is still infinity. So because it is unit step function. So this is nothing but my t minus 2. So now let us solve this problem by graphical interpretation. So let us take case number 1 as if this t minus 2 is less than minus 2. So assume that I have placed it is less than minus 2 only. So now you look at this one. So if these two signals, if I draw like this, so where is the overlapping range? So there is a overlapping range. So because this signal is from t value may be whatever, if it is less than minus 2, that means totally I am telling t minus 2 less than minus 2. So this implies, so which implies if I bring this minus 2 this side, it becomes plus 2. So that means totally t less than 0. So t less than 0 condition. So then there is overlap. There is overlap between x of tau and h of t minus tau from range I have to write. So look at here. So if this is the case, then there is a minus 2 to, so 1 is the overlapping range. So because before minus 2 x of tau is not existing, after 1, so your x of tau is not existing, hence the overlap between these two signal range is minus 2 to 1. Therefore y of t equal to integration of minus 2 to 1. So x of tau value is, amplitude value is 1. So it is also a unit step function. Its amplitude also 1. So with respect to d tau, so I am going to get this as a minus 2 to 1. So 1 into 1 is 1. So d tau, which is equal to, so integration of 1 is tau. So minus 2 to, so 1, which is equal to, I am going to get here, so 1 minus of minus 2, so which is equal to 3. So that means y of t equal to 3 is the answer for what range? So range I have to write once again here, for t less than 0. So this I have obtained. So let us look for the one more condition. That means I have placed t minus 2 less than minus 2. So now I will place t minus 2 greater than minus 2, but I have to restrict this as a, it should be less than, t minus 2 should be less than 1. So because if I write simply t minus 2 greater than minus 2 means this I can place after this 1 also, then there is no overlapping condition will exist. So hence I am restricting this t minus 2, so less than or equal to 1. So now let us see that case as a case number 2. So case number 2, so that we are going to write case number 2 for t minus 2 greater than or equal to minus 2 and t minus 2 less than or equal to 1. So that is the range I am taking. So this can be written as, so t should be greater than or equal to 0 and t should be less than or equal to, if I bring 2 this side it becomes 3. So total range becomes t should be greater than or equal to 0 but it should be less than or equal to 3. So within this range, so we are talking. Then there is overlap between x of tau and h of t minus tau from, so let us define the range. So look at here, once your t minus 2 greater than minus 2 means assume that somewhere I have placed here, so then the overlapping range becomes t minus 2 to 1. So because I can't place this t minus 2 after 1, because one more condition I have put, this t minus 2 should be less than or equal to 1. Hence the overlapping range becomes t minus 2 to 1. From t minus 2 to 1. So therefore y of t equal to integration of t minus 2 to 1. So x of tau value is 1, h of t minus tau is also 1 with respect to d tau, which is equal to t minus 2. So 1 into 1 is 1 d tau. So integration of 1 with respect to tau is tau. So t minus 2 1. So which is equal to 1 minus of t minus 2. So which is equal to 1 minus t plus 2. So which is equal to 3 minus t. So that means y of t I am getting it as a 3 minus 2. So look at the range. So 0 greater than or equal to, t is greater than or equal to 0 and it is less than or equal to 3. So now case number 3. Case number 3. So I have restricted this t minus 2 less than or equal to 1. Now it is greater than 1. I will take. That means t minus 2 greater than 1. That implies t greater than 3. So there is no overlap. So look at here. This, if I placed greater than 1 means no overlap between x of tau and h of t minus tau. So therefore I can write here, there is no overlap between x of tau and h of t minus tau. Once there is no overlap, no need to write the range. So therefore, output y of t equal to 0. So now we have to summarize this one. So totally output y of t, what I have got here, output y of t equal to, so I have got its value as a 3, and it is for t less than 0, and one more I have got 3 minus t for the range 0 to 3 range. So and its value equal to 0 for t greater than 3. So if I sketch this signal, so let us see how it looks. So simple, I am showing here the sketch of output signal y of t, how it looks like. So if at all y of t has to be sketched with respect to t, so let us make this as 1, this as 2, this as 3, this as 4. So 1, 2, 3, 4. So look at here, less than 0, its value equal to 3. Let us mark amplitude as 1, 2, 3. So now its amplitude is 3. So for all these values, the amplitude equal to 3 only. That means at minus 1, minus 1.5, minus 2, whatever you take, if it is less than 0, its value equal to 3. So on like this. Then 0 to 3 range, it is 3 minus t. So 3 minus 1, so it is equal to 2. So then it becomes like this. So that means I can mark here 3 minus 3. So I should get like this. Look at here. So its value, so approximately equal to, this is 2. So this is 1. So its value equal to 1. If I put the t value as 2, then I should get 1 amplitude. Then 3 minus 3, so is equal to 0. Then see, look at here, if it is t value greater than 3, let us take it as a 4 or 3.5u, so its value is 0 after this. So this is the sketch of y of t signal.